Welcome, curious minds, to another deep dive. Today we're embarking on a journey that spans, well, billions of years and really unimaginable distances. We're exploring the dramatic lives and deaths of stars, the tantalizing possibility of life beyond Earth, and also a critical, pretty urgent shift happening right here on our home planet.
Yeah.
We've got a truly fascinating stack of sources to unpack today. It brings together cosmic wonders and some earthly warnings, all in one narrative.
Yeah, it's a deep dive into change, fundamentally, isn't it? We'll connect the explosive ends of giant stars, which, actually enrich the universe with the building blocks of life, and then look at how some new research suggests life might thrive in really unexpected places, maybe even around dead stars.
Right.
But then we'll pivot pretty sharply back to Earth, because some models are suggesting a vital ocean current, what many of you know as the Gulf Stream, might be heading for a dramatic shift itself. And that has, well, profound and pretty immediate consequences for all of us.
Exactly. So from the farthest reaches of the cosmos, where elements are forged in these stellar furnaces, right down to the unseen currents beneath our feet that regulate our climate, we're looking at moments of immense transformation. So buckle up, because this deep dive is going to make you see the universe and maybe your place in it in a whole new, perhaps even unsettling light. Okay, with that incredible overview, let's zoom in first on the celestial stage. Our sources really dive deep into this cosmic drama of how stars live and die, these magnificent celestial engines. What's one of the most exciting recent discoveries, something that's really confirming or maybe even reshaping our models of these stellar explosions?
Well, I think what's truly groundbreaking is how recent observations are really solidifying these long-held theoretical models of stellar structure. We've always sort of imagined these colossal stars, right, maybe 60 times larger than our sun, ending their lives with an imploding iron core. And a recent discovery actually captured the explosion of such a core. It literally illuminated the lighter elements, hydrogen, helium, silicon, sulfur, that had been stripped away over thousands, maybe millions of years.
Wow.
It's like seeing the blueprint of a star confirmed in real time, pretty much proving our layered model is, well, spot on.
That's a real aha moment for astronomy, isn't it? Seeing theory confirmed in such a dramatic fashion. And speaking of drama, our sources also highlight the discovery of the brightest, most energetic supernova ever recorded. Just imagine the sheer scale of that.
It's almost beyond comprehension, really. These supernovae are just cataclysmic explosions. They're the ultimate result of a star's internal balance collapsing when it simply runs out of fuel. Gravity finally wins, the star implodes, and the resulting shock waves blast off its outer layers with just unimaginable force. And we're even observing new kind of puzzling types, sometimes described as a star being stripped to the bone, which challenges some of our assumptions about, how much mass these massive stars actually lose before they finally explode. These new observations add crucial clues to the really complex dynamics of stellar evolution.
So these stellar deaths aren't just destructive events, they're truly universe-shaping. They're like cosmic element factories, producing heavy elements like nickel, iron, cobalt, chromium, manganese. What's the sort of profound implication of these explosions for us right here on Earth?
This truly underscores that we are quite literally stardust. It sounds like a cliche, but it's true. Every atom in our bodies, pretty much, save for the primordial hydrogen, was forged in the heart of a dying star. It was scattered across the cosmos in a supernova. It's not just a poetic phrase, it's like the fundamental cosmic truth of our existence. Without these explosions, the universe would be a much simpler, much more sterile place, utterly devoid of the complexity and diversity, well, including life, that we see today. These cataclysms are the ultimate act of cosmic creation in a way.
That's a powerful thought, that the very building blocks of life come from these incredibly violent stellar ends.
It does raise an important question, though. If these elements from supernovae seed new star systems, could life find a way to arise in unexpected places? Maybe even around what we consider dead stars. Our sources suggest a surprising possibility here.
Indeed. And this is just some quirky what-if scenario. A new study suggests that Earth-like planets orbiting white dwarf stars, those glowing embers left after a medium-sized star like our sun dies, could potentially support alien life. This really challenges our assumptions about stellar longevity and the conditions needed for habitability.
That is wild. So even after a star dies, it can still provide a comfortable home. What's the mechanism? How do these white dwarf planets stay potentially warmer, maybe even more clement than planets around active stars? Well, what's fascinating here is the resilience of habitability, perhaps. This model looked specifically at two crucial processes. photosynthesis, which most life on Earth uses.
Right, converting light into energy.
Exactly. And also UV-driven abiogenesis. That's a fascinating theory suggesting how the very first life on early Earth might have spontaneously formed from non-living matter energized by ultraviolet light. The study simulated an Earth-like planet around a white dwarf for 7 billion years.
7 billion.
Yeah. A huge time frame. And found it received enough energy to sustain both processes. And get this, these white dwarf planets can actually be warmer than planets orbiting main sequence stars like our sun because they have fewer dayside clouds and a stronger nightside greenhouse effect. This creates potentially more, well, clement conditions, maybe even for billions of years.
Yeah. So this doesn't just expand our map of where life could be found then. It fundamentally shifts our understanding of what makes a star system habitable. It's urging us to look beyond just sun-like stars and consider the deep long-term future of stellar evolution as maybe a surprising cradle for life. Our sources even mention a specific planet around white dwarf WD 1054-226 that might have 1 billion years of habitability left.
Absolutely. It opens up entirely new avenues for where we might look for life. It adds billions of years to a star system's habitable lifespan, potentially. But if we connect this to the bigger picture, it also makes our own origins seem incredibly special, almost a cosmic coincidence, you know? The early Earth itself faced this period of intense comet. An asteroid impacts what's called the Late Heavy Bombardment, which made it too hot for life for its first, maybe, billion years. Life only began around 3.8 billion years ago after this subsided. And those very comets and asteroids might have delivered the water and carbon-based molecules needed. So life on Earth only started after an initial sterilizing phase, a necessary planetary maturity period, if you like.
And speaking of these critical cosmic coincidences for life, our sources bring up another key player right here in our own backyard, the moon. What's the latest thinking on its violent origins and how that might have shaped Earth's habitability?
Right. The prevailing theory, the giant impact model, suggests our moon formed about 4.51 billion years ago. It was from this massive collision between our early, still-forming planet, the proto-Earth, and a Mars-sized body. They call it Theia. And this wasn't just a violent event, it was profoundly formative.
Okay.
It remelted Earth's entire surface, it set our axial tilt and rotation, which gives us stable seasons.
Crucial.
Very crucial. And it may have delivered key life-giving elements like carbon, nitrogen, and sulfur in that impact. Without this lucky planetary collision, our planet's life-friendliness, well, it might not be a given, or it certainly would have been a very, very different kind of planet.
That really highlights just how many precise events had to line up for us to be here. And that very improbability, the unique set of circumstances, naturally sparks one of humanity's deepest questions. Which leads us right to our next frontier, actively searching for other life. So, given all these possibilities for life out there, the search for extraterrestrial intelligence, or SETI, has really intensified. Our sources highlight the Breakthrough Listen project, a massive $100 million initiative searching stars and galaxies for radio and laser signals.
Yeah, this project is truly revolutionary in its scope. It's huge. It uses powerful telescopes like Green Bank in the Northern Hemisphere and Parkes in the Southern Hemisphere. It covers 10 times more sky, scans 5 times more of the radio spectrum, and worked 100 times faster than previous searches. It's a big step up.
Wow.
They're even sensitive enough to detect what we call Earth leakage levels of radio transmission from nearby stars within about 16 light years, which means, you know, if an alien civilization just had a basic TV signal like ours from decades ago, they might pick us up and we might pick them up.
And the data is open to the public, even processed by volunteer computing networks like SETI at Home. That really reflects the idea, doesn't it? That famous line, "In an infinite universe, there must be other life." End quote. But what about objects that come to us? Our sources highlight the recent discovery of interstellar objects, or ISOs. These have certainly generated quite a buzz. What makes these objects so interesting?
ISOs are fascinating because they are, well, bodies like comets or asteroids that actually originate from other star systems. They travel through the vast emptiness of interstellar space. We've only detected 3 so far. Oumuamua back in 2017, Comet Borisov in 2019, and most recently, 3 Iclos, confirmed in 2025. What makes them so compelling is they offer this potential direct window into the composition of other solar systems, what stuff is made of out there.
And the 3I Atlas has generated quite a buzz, hasn't it? Especially with some controversy. Our sources mention Harvard astrophysicist Avi Loeb, who has controversially suggested it could be possibly hostile alien technology. Echoing similar claims he made about Oumuamua, he even co-authored a paper titled, "Is the Interstellar Object 3I Alien Technology?" What are the arguments for that hypothesis?
Loba's arguments, they're based mainly on 3ILS's unusual trajectory. It's a high speed, a different entry angle into our solar system compared to typical comets, and its close approaches to Jupiter, Mars, and Venus. He suggested its path could allow for discrete deployment of gadgets, or maybe avoid Earth-based observation because it'll be hidden by the sun at its closest approach to us. He's essentially positing that its unusual behavior is best explained by it being artificial, not natural.
But the scientific community, including NASA's lead scientist for solar system small bodies, Tom Statler, largely disagrees. Pretty strongly, it seems. Our sources describe these claims as nonsense and insulting, insisting 3 Atlas looks like a comet, does comet things. Another astronomer even described the artificial idea as nonsense on stilts. So what's the scientific consensus here, and what evidence supports a natural origin?
Right, the scientific consensus overwhelmingly points to a natural origin. While 3 Atlas does have interesting properties, it is unusual. No doubt it has a visible tail of gas, like the kind produced by comets when they're heated by the sun, and that strongly indicates it's a natural phenomenon. The nonsense on stilts comment, I think, underscores the frustration among many scientists who feel these, well, dramatic claims overshadow the real exciting science of just studying these unique interstellar visitors.
So the consensus largely dismisses the alien tech hypothesis, preferring the natural explanation. Given that, what specific technosignatures are researchers most actively looking for when they examine these ISOs or other cosmic objects, if they were artificial?
Well, this whole debate actually highlights the importance of doing rigorous technosignature searches. Researchers are looking for things like unusual maneuvers that aren't explained by gravity, artificial spectral features which would show non-natural chemical compositions in the light reflected off it, atypical shapes maybe indicating something like solar sails, or, of course, clear radio or laser signals.
Right.
There are even missions being proposed, like a study from SEORI, to perform high-speed flybys of future ISOs to investigate them up close. It's really a testament to our curiosity, isn't it? We want to know what's out there, and we need robust scientific methods to find out.
It's an incredible testament to our curiosity, absolutely. Whether they are natural or not, these isotopes offer a direct window into the composition of other solar systems, expanding our understanding of the universe. Okay, now, after traversing billions of years and unimaginable distances, exploring cosmic creation and alien speculation, it's time to bring our focus sharply back home. Because while the universe offers these grand transformations, our own fragile blue marble faces a profound and very human-caused challenge right here beneath our feet. Our sources highlight urgent warnings about the Atlantic Meridional Overturning Circulation, or AMOC, often just called the Gulf Stream. For those who might be unfamiliar, what exactly is the AMOC and why is it so vital?
The AMOC is a truly vital ocean current system. You can think of it like a global conveyor belt. It moves vast quantities of oxygen, nutrients, carbon, and crucially heat around the globe. Warm, salty water flows north from the tropics near the surface. It cools, gets denser, sinks deep in the North Atlantic, and then flows south in the deep ocean. And along the way, it releases immense amounts of heat into the atmosphere. This process significantly moderates the climate, especially in northern Europe. It prevents it from having winter temperatures like, say, Siberia or much of Canada at the same latitude. It's a massive planetary thermostat.
And here's where the alarm bells really start ringing. Our sources reveal that some scientists are warning the AMC is weakening due to climate change, and it could be on the verge of collapse. One study suggests the window for this collapse could begin as early as 2025, with maybe a 50% probability the next 10 years and 99% within 50 years. The researchers behind it even admitted they were bewildered by their own findings, said the result annoyed them because of how close and significant it is. What would such a collapse truly mean for Northern Europe, and maybe even beyond?
Yeah, this raises an extremely important and, frankly, quite dire question. A collapse would mean profound cooling in Northern Europe. Winter temperatures could drop by up to 10 degrees Celsius, maybe more in some places, making the climate much more like Siberia or northern Scandinavia. You could expect vastly increased winter storms, greater day-to-day temperature swings, and extensive sea ice expanding down towards northwest European coasts. That sea ice would further amplify the cooling by reflecting sunlight back into space. It would be a dramatic and rapid shift, really unlike anything modern civilization has experienced.
It's almost hard to grasp the scale of that change. Imagining cities like London or Paris grappling with winters that rival Siberia, it puts a very personal face on these huge global systems, doesn't it? And it's not just Europe, right? Our sources indicate a collapse would lead to a significant rise in sea levels on the eastern coast of North America, which would worsen coastal erosion and flooding in cities like New York, Boston. It would also severely disrupt the global water cycle, causing droughts, famines, flooding in places like India, South America, West Africa. Millions could be affected, enduring both colder and more extreme weather patterns globally.
It's really a cascading nightmare scenario. However, as our sources also show, it's a topic with significant scientific debate. It's not completely settled science yet. While the concern is widespread and very real, other climate experts point to big uncertainties in the models used to predict this. For instance, some models rely heavily on sea surface temperature changes as an indicator for AMOC strength. But others argue that salinity, the saltiness of the water, is actually a more direct proxy, and we have less long-term data on that.
Okay, that makes sense.
And some studies looking at the Florida Current, which is kind of the beginning of the Gulf Stream system, suggest maybe more stability there in recent times. It really highlights the immense complexity of trying to predict such a massive interconnected system. But importantly, it doesn't diminish the urgency of the concern.
So it's not a fully settled matter in the scientific community, but it's clearly a critical area for immediate, intense research. What are the next steps for researchers then? And what does this debate imply for how we should be thinking about these potential climate tipping points?
Well, the researchers behind that 2025 study, they plan to update their model with the latest data to try and narrow down their predictions. Sharpen the focus. This debate implies we need to approach these complex systems with both caution and, frankly, humility. We need more comprehensive long-term observational data across various indicators, temperature, salinity, flow rates, and we need to keep refining our climate models. But critically, even with the uncertainties, the potential for such a rapid, catastrophic shift means we probably need a proactive rather than reactive approach to climate action. The scientific discussion isn't really about whether the climate is changing, it's more about how fast and how fundamentally these crucial Earth systems might respond.
Wow, what a deep dive that was. We've spanned the life and death of stars, the incredible journey of the building blocks for life, the thrilling, sometimes controversial search for alien intelligence, and the stark reality of our own planet's changing climate. It's truly a humbling reminder of the immense forces at play in the universe and the delicate balance that supports life right here.
Indeed. From supernovae enriching the cosmos, to the surprising possibility of life around white dwarfs, to the critical role of maybe a lucky collision for Earth's own habitability, the universe is just a place of constant, profound change. And now, we see that our own planet is clearly at a critical juncture, facing changes that could reshape our future in pretty dramatic ways. It demands our attention and probably our action.
It really leaves you with so much to ponder, doesn't it? So as you reflect on this journey through cosmic creation, alien speculation, and Earth's delicate balance, consider this. How will humanity choose to navigate its own Goldilocks zone, both, in the grand scheme of the universe and on the fragile blue marble we call home? What steps do you think are most urgent for us to take, given these intertwined cosmic and earthly transformations?